Hi, Mrs. Jacobs here, physics teacher at Naperville North, and I'm here to talk about the key ideas about velocity versus time graphs. What we found when we ran the buggies with a position graph, the buggies in front of the motion detector. So for example, let's say the buggy was moving away from the motion detector in a positive direction. Let's call that segment A. And then was at rest during segment B, and not moving, we looked at what does the velocity graph look like when the position graph is like this. And what we found is key idea number one, the velocity graph only has flat segments. Okay. When I was moving in a positive direction on the velocity graph, there was a flat segment that was above the x-axis, like this. Now it wavered a little bit, it wasn't perfectly constant, but overall it was flat. Then when the object stopped moving, it dropped down here and there was a flat segment on the x-axis, which means it is at zero velocity and is not moving. Okay. So what's interesting is a flat line on a velocity graph means motion. If it's above zero, it means it's moving in the positive direction. If it's below zero, let's do a situation like this, where it starts away from the motion detector and heads towards it, and then is at rest. If there's a segment here where it's moving in the negative direction, that will show up on the velocity graph below zero as a flat line, because that means I'm moving at a constant negative velocity. My velocity is the same meters per second, and I'm not speeding up or slowing down, but I am moving in the negative direction. Then when I'm at rest, I would hop up here to the x-axis, and that's what we saw on the screen of the LabQuest when we were using the motion detector. So key idea number two, we said, was the only way to show at rest on the velocity graph is to have a segment on the x-axis. Okay. If I'm above the x-axis, I'm moving at a constant positive velocity. If I'm below the x-axis, I'm moving at a constant negative velocity. Now, we did see with the motion detector that there was a little bit of a segment here where there was with a slope and it was either speeding up or slowing down. We are going to kind of gloss over that for this unit, and we're just going to connect these two segments with a vertical line to say, like, I was moving in the negative direction and then I was stopped. We're going to skip over the part where I was speeding up or slowing down because we will cover that in a different unit. Okay. Let's tackle one more key idea. Let's say I have a position versus time graph where segment A is moving fast in the positive direction. Segment B is at rest. And segment C is slow in the negative direction. I like how we're being interrupted by the announcement. What would the velocity graph look like for this? Okay. The theme is, remember that this position graph and this velocity graph are going to have different shapes, but this velocity graph must tell the same story of motion, even though it has a different shape. Okay. So if I'm fast in the positive direction, I have to have a flat line that's above the x-axis on my velocity graph. So that is segment A. Then segment B is at rest. The only way to show that on a velocity graph is to have a segment here on the x-axis at zero. Now, C is going to be in the negative direction. It's going to be below the x-axis, but the question is, how do I show that it's moving more slowly than A? Will that be a segment that's closer to the x-axis or farther away from the x-axis? When in doubt, put some numbers on it. Let's say this is -1 meters per second, -2, -3, -4. What is faster? Or in this case, this is a slower segment. So what's slower, -1 meter per second or -4 meters per second? The answer is -1 meter per second is slower than -4 because it covers less meters every 1 second. Okay. -4 meters per second would be faster. So here I'm seeing another key idea is whenever I have a segment that's slower or faster, it matters where it is relative to the x-axis. A faster segment is farther away from the x-axis on the velocity graph. Okay. Hopefully this was helpful for you to understand how to go from a position graph to a velocity graph.